Hello everyone, Dennis here. In this video, I'm going to discuss with you GCE O-Level Physics October-November 2022 paper 1. The subject code is 6091. Alright, now let's start discussing the paper. Question 1. A textbook lists the diameter of a hydrogen atom as 1.1 times 10 to the power of negative 10 meters and the diameter of the Earth as 1.3 times 10 to the power of 7 meters. How are these values expressed with prefixes? So here are a few choices. The first column is diameter of hydrogen atom and the second column is diameter of the Earth. So option A, 1.1 times 10 to the power of negative 1 nanometers, 1.3 times 10 to the power of negative 2 gigameters. Option B, 1.1 times 10 to the power of negative 1 nanometers, 1.3 times 10 to the power of negative 2 megameters. Option C, 1.1 times 10 to the power of negative 1 micrometers, 1.3 times 10 to the power of negative 2 gigameters. Or option D, 1.1 times 10 to the power of negative 1 micrometers, 1.3 times 10 to the power of negative 2 megameters. The answer, let's recall prefixes. So here is a list of prefixes for large value. Mega and giga are 10 to the power of negative 6 and 10 to the power of 9 respectively. And this is the list for small values. Micro and nano are 10 to the power of negative 6 and 10 to the power of negative 9 respectively. So let's see the first value, the diameter of a hydrogen atom is 1.1 times 10 to the power of negative 10 meters. So we can write as 1.1 times 10 to the power of negative 1 minus 9 meters. Then we split them into two different body. So we have 1.1 times 10 to the power of negative 1 times 10 to the power of negative 9 meters. So 10 to the power of negative 9 meters will be nanometer. Hence, it is 1.1 times 10 to the power of negative 1 nanometers. We'll do the similar process for the diameter of the Earth, which is 1.3 times 10 to the power of 7 meters. It can be written as 1.3 times 10 to the power of negative 2 plus 9 meters. Then split them into 2, we'll get 1.3 times 10 to the power of negative 2 times 10 to the power of 9 meters. So 10 to the power of 9 meters is gigameters. Hence, the value is 1.3 times 10 to the power of negative 2 gigameters. Therefore, the answer is A. Diameter of hydrogen atom is 1.1 times 10 to the power of negative 1 nanometers, and diameter of the Earth is 1.3 times 10 to the power of negative 2 gigameters. Question 2. A car is traveling at 10 meters per second due north. It reaches a bend and a short time later it travels at 10 meters per second due east. Which statement must be correct? A. The car changes its speed but has no acceleration. B. The car changes its speed and accelerates. C. The car changes its velocity but has no acceleration. And D. The car changes its velocity and accelerates. The answer is D. the car changes its velocity and accelerates. So what is the reason? So now let's see the question. So this car is traveling at 10 meters per second due north. We can treat this as the velocity. So to illustrate, it travels to the north direction with the speed is 10 meters per second. And we can also represent it in velocity, which is a vector. So we can represent in vector form. You can write as 0 x direction plus 10 y direction meters per second, because it travels to the north. So this will be the y direction, then y direction. Next, it travels due east. The speed is 10 meters per second. But for velocity, we can write as 10x plus 0y meters per second, because now the direction is to the east. So to the right, we treat as the positive x. Then it becomes 10x plus 0y meters per second. So from here, you can see that the x direction, it changes from 0 to 10 meters per second. For the y direction, it changes from 10 to 0 meters per second. Okay, so we can check one by one for the option that we have. So it changes its speed but has no acceleration. As long as you have the speed, you must have an acceleration. So this option does not valid. For B, it changes its speed and accelerates. As you can see from here, whether it travels to the north or to travel to the east, the speed is still the same, which is 10 meters per second. Hence, this option is incorrect. C, the car changes its velocity but has no acceleration. Okay, so this is similar with option A. Since it changes the velocity, they must have an acceleration. For D, the car changes its velocity and accelerates. As you can see here, right, the velocity has changed, and if you have the changes in velocity, they must have an acceleration. Question 3. An object is falling vertically near the Earth's surface. At time t equals 0, it has a speed of 25 meters per second downwards. Air resistance is negligible. What is the speed at t equals 2.0 seconds? Is it A, 5.0 meters per second, B, 25 meters per second, C, 45 meters per second, or D, 50 meters per second? So to get the answer, first we assume the acceleration A equals g, which is 10 meters per second square, because the object is falling vertically near the Earth's surface. Hence, the acceleration equals to g, which is 10. Then we apply the formula v equals u plus at, where the u, which is the initial speed, is 25, a is 10, and t is 2. So v equals 25 plus 10 times 2. Then we calculate the value of v. We have 45 meters per second. Hence the answer is C, 45 meters per second. Question 4. A train travels in a straight line and decelerates uniformly as it comes into a station where it stops. So here are given 4 graphs where graph P and graph Q are displacement time graph, and graph R and graph S are velocity time graph. Which two graphs represent the motion of the train? A, P and R, B, P and S, C, Q and R, or D, Q and S. Alright, so to obtain the answer, let's look at the keywords from the question. So this train decelerates uniformly. So when it decelerates uniformly, you talk about the velocity time graph, it must be a straight line. Okay, because when it is a straight line, the gradient is constant. So the gradient of velocity time graph represents the acceleration. Okay, so this is a negative gradient, means negative acceleration or positive deceleration. Okay, compared to graph S, So this velocity time graph does not represent what is described in the question because it is a non-uniform deceleration. As you can see, it is a curve. Okay, so when it is a curve, the gradient for every point on the curve are different. Okay, again, because the gradient represents the acceleration, so it becomes a non-uniform deceleration. Alright, so this will be the correct graph. Now we move on to graph P. So what's wrong with graph P? So as you can see, this is a displacement time graph. When it is a straight line, it means the velocity is constant. Alright, so remember displacement time graph, the gradient tells us the velocity of the motion. Okay, so in a straight line, the gradient will be constant, which means the velocity is constant. Hence, this is not the correct graph. For graph Q, this is the correct displacement time graph. As you can see, it is a curve. And again, the gradient of displacement time graph tells us the velocity. So at first, the gradient for this graph is greater than the gradient at the end of the time. Alright, so the gradient tells the velocity. At first, it travels very fast, but at the end of the time, it travels very slow until it comes to a stop. Okay, so the velocity is changing. So this will be the correct correct graph, displacement time graph. Hence the answer is C, Q, and R. Question 5. A ball is dropped vertically downwards from a tall bridge. What is the motion of the ball when air resistance is increasing, and what is the motion of the ball when air resistance equals the weight of the ball? So here are a few options. For the first column, it is motion when air resistance is increasing, and the second column is motion when air resistance equals weight. So option A, decreasing acceleration, uniform non-zero acceleration. Option B, decreasing acceleration, uniform velocity. Option C, decreasing velocity, uniform non-zero acceleration. Or option D, decreasing velocity, uniform velocity. To obtain the answer for question 5, first we need to draw the free body diagram for this ball. Okay, so this ball is dropped vertically downwards. So the force applied here will be the weight of the ball, which is equals to mg. So we have the air resistance pointing upwards while when the ball is dropped vertically downwards. So let's label this air resistance as Fa. So the resultant force for this free body diagram will be equals to mg, the weight, minus the air resistance. Okay, so we also know that the resultant force F equals to ma. Okay, so the equation becomes ma equals to mg minus air resistance. Then we make A the subject, so A equals mg minus air resistance over m. Now let's move on to see what will happen to the motion when the air resistance is increasing. So let's look at this formula, right? So mg is a constant, the mass also is a constant, only then minus with the air resistance. So this acceleration minus something that is increasing will happen to the acceleration. So it will decrease. Hence the acceleration will decrease. Option A and option B are correct, decreasing acceleration. While option C and option D are incorrect because they mention about decreasing velocity. Okay, now let's check the second situation here. What happened to the motion when air resistance equals weight? Alright, so when air resistance equals to the weight, look at this formula again. So these two values are the same. Hence, when these two same value minus each other, we'll get 0 resultant force. So resultant force is ma equal to 0, but the mass is constant, hence the acceleration is 0. So from here, we can say that option A and option C are incorrect because they mention about non-zero acceleration. And option B and option D are correct because it is a uniform velocity. Since there is no acceleration, then we have uniform velocity. Hence, the answer is B. Motion when air resistance is increasing, then we have decreasing acceleration. And motion when air resistance equals weight, we'll have uniform velocity. Question 6. Water in a container exerts forces on the walls of the container. The walls of the container also exerts forces on the water. Which diagram shows the forces that the walls exert on the water? So here are the four options: option A, option B, option C, and option D. To obtain the answer for question 6, we need to relate it to Newton's third law. Based on Newton's third law, for every action, there is an equal and opposite reaction. So for option C, this is how water exerts forces to the wall of container. Hence, this is not the answer because we want the diagram that shows the forces that the walls exert on the water. So it will be diagram D. The wall of container also exerts equal and opposite forces. Hence the answer is option D. Question 7. An object of mass 20 kilograms is falling vertically downwards in the Earth's atmosphere. The air resistance acting on the object is 80 newtons. In which direction does the force of air resistance act on the object, and what is the acceleration of the object? So here are a few options. So option A, the direction of air resistance is downward, acceleration is 6.0 meters per second. Or option B, direction of air resistance is downward, acceleration is 14 meters per second square. Option C, direction of air resistance is upward, and acceleration is 6.0 meters per second square. Or option D, direction of air resistance is upwards and acceleration is 14 meters per second square. So to obtain the answer for question 7, we need to draw the free body diagram of the object. So it is exactly the same as question 5. We have an object falling downwards with a weight of equals mg and air resistance pointing outwards. So the resultant force equals the weight minus the air resistance, or ma equals to mg minus air resistance. Okay, then we substitute the values given into this equation. The mass is 20, so we have 20a. So this is m times g, which is 10. 20 times 10, the air resistance is 80 newtons here. Okay, we solve this equation. We have 200 minus 80 over 20. Calculate, we'll get 6.0 meters per second square. Okay, so the air resistance is pointing outwards and the acceleration is 6.0 meters per second. So the answer will be C. Question 8. What is a gravitational field? A. A region where a force experiences a gravitational attraction due to its mass. B. A region where a force produces a mass due to gravitational attraction. C. A region where a gravitational attraction produces a mass due to its force. Or D. A region where a mass experiences a force due to gravitational attraction. So this is a very textbook based question. Okay, so where is the gravitational field? It is the region where any mass or any object within this field, whether it is further away from the Earth or very close to the Earth, as long as they have mass, all of them will be attracted towards the center of the Earth. Okay, so this region will be the gravitational field. So by definition, it is a region where a mass experiences a force due to gravitational attraction. So the answer is D. Question 9. Given this diagram, a uniform rule rests on two supports. Three forces X, Y, and Z act on the rule. How are the sizes of the forces related? A. Y is greater than X greater than Z. B. Y greater than Z greater than X. C. Z greater than X greater than Y. Or D. Z greater than Y greater than X. To obtain the answer, so let's look at the question. The keyword is at rest, which means the rule is in equilibrium state. So when the rule is in equilibrium state, hence force Y will be equals to the sum of force X and Z. Why? Because force Y is pointing downwards, while force X and Z are pointing upwards. Okay, so since it is in equivalent states, then force Y will equals to force X plus Z. Based on this equation, then the force Y is greater than X, and also force Y is greater than force Z. Alright, so next we also want to consider the moment for this question. So we'll label this distance as t1 and this distance as t2. So based on the principle of moments, where when the object is in equilibrium states, the sum of the clockwise direction moment equals to the sum of anti-clockwise moment. So we will choose point Y as the pivot. So the clockwise moment will be d1 times x, and the anti-clockwise moment will be d2 times z. So the formula becomes d1 x equals d2 z. So based on this diagram, we can see that distance 1 is greater than distance number 2. Okay, so this is greater than this one. Therefore, to make this equation to be equal, z must be greater than x. Hence, z is greater than x. So we combine these ranges or inequalities together. We have y is greater than z greater than x. Hence, the answer is B. Question 10. Given this diagram, the diagram shows a hydraulic press with two pistons. The pressure on piston 1 exerted by the oil is P1. So let's label this point as P1. The pressure on piston 2 exerted by the oil is P2. So let's label this point as P2. The pressure at point X is P. So we label this as P. How do P1 and P2 compare with P? Option A, P1 equals P2 and P2 is greater than P. Option B, P1 is less than P and P2 is greater than P. Option C, P1 equals P2 and P2 is less than P. And option D, P1 is greater than P and P2 is less than P. To compare the pressure on this diagram, so let's look at these 2 points. They are at the same level. Okay, so since these 2 points at the same level, then pressure 1 equals to pressure number 2. So we have atmospheric pressure pressing down the piston from outside. Okay, so since these two pistons are in equilibrium states, so that means P1 will be equals to atmospheric pressure, same as P2 will be also equals to the atmospheric pressure. Okay, next we want to find the pressure at point X here. So this will be the height of point X to the top level of the oil. Okay, so the pressure at this point will be the atmospheric pressure for outside plus with the pressure by the oil. So we can use this formula H rho G to calculate the pressure of liquid, which is oil for this case. Okay, so as you can see from the equation here, the pressure P will be greater than P2 because we have the pressure from the oil. Hence, the answer is C, P1 equals to P2 and P2 is less than P. Question 11. Which statement about energy is correct? A. During a transfer of energy within a system, energy always goes from one object to another. B. During a transfer of energy within a system, the total energy before and after the transfer are always equal. C. When a motor does work, the total input energy always equals the useful output energy. Or D. When a motor does work, the total input energy is less than the useful output energy. To answer this question, we need to relate it to the principle of conservation of energy, which states that the total amount of energy in an isolated system is constant. Energy cannot be created or destroyed. It can be converted from one form to another. So let's look at this diagram. We have input energy. It is equals to the useful output energy plus waste energy. So this diagram will represent the equation. We have input energy going into the isolated system. You produce two products, which is useful output energy and waste energy. Alright, so based on the description from these four options, B will be correct. During a transfer energy within a system, the total energy before and after the transfer are always equal. Alright, so what's wrong with option A? So the energy not necessarily have to go from one object to another. For option C, the total input energy is not always equals to the useful output energy. We need to consider with the waste energy as well. For option D, the total input energy will not be less than the useful output energy. We can look at this equation. So if this input energy is less than the useful output energy, then it will become a negative value. Energy cannot be negative value. Question 12. Given this diagram, a car moves down a hill from P to Q with the engine turned off. There is a constant backward force F on the car in the direction shown. Alright, so this is the F pointing this direction. And this car moves downhill from point P to point Q. In traveling 50 meters from P to Q, the car loses 100,000 joules of gravitational potential energy and gains 20,000 joules of kinetic energy. So what is the value of this F? So is it option A, 400 newtons, option B, 1,600 newtons, option C, 2,000 newtons, or option D, 2,400 newtons? Okay, so based on the principle of conservation of energy that we have discussed in previous question 11. Okay, so the input energy will be equals to the output energy plus with the waste energy. Alright, so for this case, the energy that losses will be the gravitational potential energy, GPE. So when it loses the GPE, so this energy will transfer to another form, which is the kinetic energy, and the work done by the force. Okay, where with this force is the uh, this one, the backward force here. All right, so now we substitute the values given here. The loss of GPE will be 100,000 joules. The KE gain, the kinetic energy gain is 20,000 joules. The work done will be the force multiplied with the distance traveled. Okay, D here. So where the D is 50. Okay, 100,000 minus 20,000, we get 80,000. So the force will be 80,000 divided by 50, which is 1,600 newtons. And the answer is B. Question 13. A student has a small block of metal and wants to show that it is a magnet. Which test shows that the metal block must be a magnet? A. It is attracted to a small block of the same metal. B. It is not attracted to a small block of aluminium. C. It is attracted to one pole of a magnet. D. It is repelled by one pole of a magnet. The answer is D. It is repelled by one pole of a magnet. Remember to test if whether a material is a magnet or not. The repulsion test will be used. Okay, so even if it is attracted to one pole of the magnet, we still can't tell whether this block of metal is a magnet or not, because magnets can attract magnetic materials. Alright, so similarly with this one, option A, it attracted to a small block of same metal. So for this case, this metal may be a magnet, but the small block of the metal owned by this student may not be a magnet. Alright, so the answer is D. Question 14. Thermal energy is supplied continuously to water in a kettle to keep the water boiling. As the water boils, molecules escape as vapor. The water vapor above the water in the kettle is at the boiling point of water. How do the molecules of water in the vapor compare with the molecules in the liquid water? A. Their average kinetic energy is greater and the force between them is smaller. B. Their average kinetic energy is greater, but the force between them is the same. C. Their average kinetic energy is the same, and the force between them is the same. Or D. Their average kinetic energy is the same, but the force between them is smaller. To obtain the answer for question 14, we need to understand internal energy. So there are two energies under this category. The first one is the potential energy, and the second type is the kinetic energy. Potential energy is responsible for the state of matter where it will change during freezing, boiling, or melting. For kinetic energy, it is responsible for the temperature of the object. Hence, from this question 14, the water vapor above the water in the kettle is at the boiling point of the water. So the keyword here is boiling point. In other words, the temperature is fixed. Alright, so since the temperature is fixed at boiling point, which is 100 degrees Celsius, hence option A is option B is incorrect, because it says the kinetic energy is greater. Remember, kinetic energy is responsible for the temperature of the object. The more kinetic energy it has, then the higher the temperature it will have. Alright, now for option C, the force between them will not be the same, because when it is in water vapor, which means it is a gas state. So the force between the molecules will be smaller. Alright, hence option C is incorrect. For option D, kinetic energy is the same because the temperature does not change. They are in the boiling point. The forces between them is smaller because it is water vapor. It is in a gas form, hence the forces between them is smaller. So the answer is option D. Question 15. A cylinder contains gas. The volume of the cylinder is constant. Which change to the mass of the gas and which change to its temperature each result in an increase in pressure. So here are the options for the change in mass and change in temperature. Option A, decrease in the change in mass, decrease in the change in temperature. Option B, decrease in mass, increase in temperature. Option C, increase in mass and decrease in temperature. Or option D, increase in mass, increase in temperature. Okay, to obtain the answer for question 15, first look at the information given from the question. So this is the volume of the cylinder is constant. Alright, the next keyword is result in an increase in pressure. So I want the pressure increase when we change the mass and change the temperature. So the answer is D. It will increase the mass so that we have more molecules in the gas, hence the frequency of collision for the molecule of gas to the wall container increases. So this will increase the pressure. Similarly, when we increase the temperature, then the molecules will receive more kinetic energy. Hence, the frequency of collision between the molecules to the wall is higher, and every time the molecules of the gas collide with the wall or container, the force will be greater. So this will result in an increase in the pressure. Question 16. A beaker of water is heated at the bottom to form a convection current in the water. An explanation of the convection current contains 4 statements. 1. The water at the bottom becomes warmer. 2. The density of the water decreases. 3. Less dense water rises and cold water moves in to replace it. 4. Water expands. Which is the correct order of these statements? A. 1, 2, 3, 4. B. 1, 3, 4, 2. C. 1, 4, 2, 3. Or D. 1, 4, 3, 2. The answer is C. Number 1. The water at the bottom becomes warmer when the water is heated at the bottom of the beaker. So once it is heated, the water expands. So when the water expands, that means they will have a change in density. So the density of the water will decreases because it is heated. What will happen next is the less dense water rises and the cold water will move in to replace it. So the order will be 1, 4, 2, 3. Question 17. A thin sheet of material is shiny and white. It is used to wrap around the athlete who has run a race. What is the effect of the sheet being shiny and white rather than dull and black? A. It reflects less radiation from the athlete and the athlete cools down more quickly. B. It reflects less radiation from the athlete and the athlete cools down more slowly. C. It reflects more radiation from the athlete and the athlete cools down more quickly. Or D. It reflects more radiation from the athlete and the athlete cools down more slowly. So the answer is D. It reflects more radiation from the athlete and the athlete cools down more slowly. You are still wondering what is this about? So let's take a look from this picture. As you can see, there are many athletes here. They may have completed certain marathon. So once they have reached the finishing line, they wrap around themselves with a thin sheet of, as described in the question, a thin sheet of material which is shiny and white. Okay, so why the answer is D, right? So there are two parts here. First, it is about why it is shiny and white, okay, compared to dull and black. So the color of the material, right, will decide whether will reflect or absorb more heat by radiation. Okay, so shiny and white sheet, right, will reflect more radiation, okay, instead of less radiation. So option A and option B are incorrect. Then the second part, whether the athlete cools down more slowly or cools down more quickly. Alright, so we need to cool down slowly because we don't want to lose heat too fast from our body, where we will have a risk of having hypothermia. Okay, what is hypothermia? That means if we lose the heat too fast from our body, and we might just fainted because of that. Alright, so that's what the answer is D. Reflect more radiation, and we want to cool down the athlete slower. Question 18. A thermometer is made by taking wires of two different metals and joining them at each end. One junction is always kept in a beaker of melting ice. So here is the diagram to illustrate what is described here. So actually this is a thermocouple thermometer. So the voltmeter measures the electromagnetic force EMF produced when the junctions are at different temperatures. The second junction, which is this part, is placed in hot water at 80 degrees Celsius, and the voltmeter reading here is 9.6 microvolts. What is the temperature of the second junction when the reading on the voltmeter is negative 1.8 microvolts? So options: A, negative 15 degrees Celsius, B, negative 10 degrees Celsius, C, 10 degrees Celsius, or D, 15 degrees Celsius. Alright, so to obtain answer for question 18, we need to apply the formula for the thermocouple thermometer, where the change of the temperature 1 over the change of the voltmeter reading 1 equals to the change of the temperature number 2 over the change of the voltmeter reading for the second situation here. Alright, so remember that for a good thermometer, right, it must be linear in terms of changing its temperature versus the change of another parameter here. Okay, so for this case, let's take the theta 1 and V1 is the one that we want to find here. Okay, theta 2 and V2 for this case is the given information here. Okay, the change of the temperature 1, so will be 0 because it is the co-junction is at the melting ice. Theta 1, okay, is the one that we want to find, over the change in voltmeter 1, so it will be 0 minus negative 1.8. Okay, so remember when it is in the melting ice, the voltmeter will be 0. Now the second scenario, the change of the temperature, so it is given here, right? It is 80 degrees Celsius when the reading is 9.6 microvolts. Okay, so it will be 80 minus 0 degrees Celsius and over 9.6 minus 0. Okay, and we solve this equation. We have negative theta 1 over 1.8 equals 25 over 3. So theta 1 will be 25 over 3 times negative 1.8 which is negative 15 degrees Celsius. Hence, the answer is negative 15 degrees Celsius. Question 19. The water in a swimming pool has a temperature of 28 degrees Celsius and the hot water in a kettle has a temperature of 80 degrees Celsius. Where does the water have the greater total internal energy, and where do the water molecules have the greater average kinetic energy? So here are a few options. For the first column is the greater total internal energy, and the second column is greater average kinetic energy. So option A, in a kettle we have greater total internal energy, and in a kettle also have the greater average kinetic energy. Option B, in a kettle, in a pool. Option C, in the pool, in a kettle. Or option D, in the pool and in the pool. Okay, so the answer will be C. In the pool, it has greater total internal energy compared to the kettle because the amount of water in the pool is much greater than the amount of water in the kettle. So it will have greater total internal energy. However, when we talk about average kinetic energy, the kettle has greater average kinetic energy because it has higher temperature compared to the temperature in a swimming pool. Therefore, the answer is C. In a pool, we have greater total internal energy, and in a kettle, we have greater average kinetic energy. Question 20. A 500 watt heater is placed in a boiling liquid. It takes 10 minutes for 360 grams of liquid to turn into a gas. All the thermal energy supplied by the heater is used to convert the liquid to gas. What is the specific latent heat of vaporization of the liquid? A. 1.4 times 10 to the power 1 joules per kg. B. 8.3 times 10 square joules per kg. C. 1.4 times 10 to the power 4 joules per kg. Or D. 8.3 times 10 to the power 5 joules per kg. Okay, so to get answer, we need to do some calculations here. So we want to find the specific latent heat of vaporization. So we use the formula of this specific latent heat of vaporization, LV, equals to the energy divided by the mass. But we are given the power, so energy will be the power multiplied with the time in terms of seconds. Okay, so we can now start to fill up the information given. The P, where power is 500 times the time given is 10 minutes. It will convert to seconds, so I multiply by 60, then divide by. So this is 360 grams. I want my answer in kg, so convert to kg becomes 0.36. Then calculate everything together. We have 833,333. Okay, so I want it in this standard form. So it becomes 8.3 times 10 to the power 5 joules per kg. The answer will be D. Question 21. Which graph shows how the period of a wave is related to its frequency? So here are the graphs. To answer this question, we need to relate it to this formula, F equals 1 over T. As you can see from this formula, the frequency F is inversely proportional to period T. Hence, among these four options, option B shows that the relationship between the frequency and the period is inversely proportional. Hence, the answer is B. Question 22. What is a wavefront? A. A line along the crest of a wave. B. The distance between two consecutive crests. C. The first wave produced by a source. Or D. The transfer of energy by oscillations. So based on the definition from the textbook, a wavefront is imaginary line connecting points that are in the same phase. So between these four options, option A, a line along the crest of a wave is the answer because all the points on the crest are in the same phase. So this line is an imaginary line that connects the points on the crest which are in the same phase. Okay, next question 23. Which row shows the nature of ultraviolet and of ultrasound waves? So here are the options, ultraviolet and ultrasound. Whether ultraviolet is longitudinal or transverse wave, and ultrasound, is it a longitudinal wave or transverse wave? Alright, so the answer is C, transverse wave for ultraviolet and longitudinal wave for ultrasound. This is because ultraviolet is one of the waves in the electromagnetic spectrum. So electromagnetic waves are transverse wave. So for ultrasound, it is a sound wave, hence sound wave is a longitudinal wave. The answer is C. Question 24. Given this diagram, the diagram shows a ray of light traveling through a semicircular glass block in the direction shown. Angles P, Q, R, and S are measured in degrees. What is the refractive index of the glass? A. Sin 90 degrees minus P over sin 90 degrees minus Q. B. Sin 90 degrees minus R over sin 90 degrees minus S. C. Sin P over sin Q. Or D. Sin R over sin S. So to obtain the answer for this question, first let's take a look of the refractive index formula. N equals sin I over sin R, where I is the incident angle, R is the refractive angle. So we need to find what is the incident angle and the refractive angle from this diagram. So this will be the incident angle. This is also the incident angle. Alright, so either when the ray entering the glass block, the angle made from this incident ray to the normal will be the incident angle, or when the ray exits the glass block, so the angle formed by the ray and the normal will be the incident angle. Okay, so hence from this diagram, the incident angle will be 90 degrees minus P, which is this angle, or 90 degrees minus S, which is this angle. So this angle will be the refractive angle, and this angle also will be the refractive angle. Okay, so refractive angle for this one will be 90 degrees minus Q, and for this angle will be 90 degrees minus R. Okay, so again, maybe let's think about what's refractive angle. So it will be the angle formed between the ray and the normal in the glass block here. Okay, so it can be this or this. Alright, so from here we have 90 degrees minus P and for the incident angle, and 90 degrees minus Q for the refractive angle. So the answer will be A, sin 90 degrees minus P over sin 90 degrees minus Q. Question 25. Which diagram shows a diverging lens refracting two parallel rays of light? So here are the options. So the answer will be D. Okay, and this is the focal point of the diverging lens. Remember that for a diverging lens, it will diverge the ray that passes through it. So the answer will be D. Question 26. A boy stands at a distance of 85 meters from a large wall. He claps his hand once and hears an echo from the wall. He then claps at regular intervals. He increases the rate of clapping until each clap is made just as he hears the echo from the previous clap. Sound travels through air at speed of 340 meters per second. Which frequency of clapping does he reach? A. 0.25 Hz, B. 0.50 Hz, C. 2.0 Hz, or D. 4.0 Hz. To illustrate the situation here, let's look at this diagram. So the boy is at a distance of 85 meters from this wall. So this is how the sound travels from the boy towards the wall, then bounce back and travels back to the boy. So the total distance traveled by the sound is 2 times of 85 meters. From the formula of speed, S equals d over t, where d is the distance, t is the time. So we rearrange the formula to make the time the subject, t equals to d over s. So the distance is 2 times 85, then divided by the speed, which is 340 meters per second. We calculate the value, the time is 0.5 seconds. Then to get the frequency, we use the formula F equals 1 over t, which is 1 over 0.5 for this case, and we get the frequency is 2 Hz. Hence, the answer is C, 2.0 Hz. Question 27. Which diagram shows the direction of the current I and the direction of electron flow E in a circuit? So here are the 4 options. Remember that the direction of the current I flows from the positive terminal of the battery to the negative terminal of the battery, while the direction of electron flow will be from the negative terminal of the battery to the positive terminal of the battery. Hence, among these 3 options, option A is the correct answer. Question 28. A 12-volt car battery is connected to a lamp labeled 12 volt 24 watts. The lamp shines at normal brightness for 25 hours. What is the size of the charge that passes through the lamp at this time? A. 3000 coulomb, B. 45,000 coulomb, C. 180,000 coulomb, or D. 1,100,000 coulomb. To determine the size of the charge that passes through the lamp at this time, so we use the formula of power, P equals VI, where P is the power, V is the voltage, and I is the current. And we know that current is the rate of flow of the charge. Hence, the formula becomes P equals V times Q over T. Then we rearrange the formula to make Q the subject. Hence, the equation becomes Q equals PT over V. And now we can substitute the values given. The power is 24 watts. The time is 25 hours. They multiply by 60 minutes and multiply by 60 seconds and divided by the voltage, which is 12 volts. Then we calculate, the answer becomes 180,000 coulomb. Hence, the answer is C, 180,000 coulomb. Question 29. During a lightning strike, there is a current of 300 kA between a charged cloud and the Earth for 5.0 milliseconds. It releases 450 megajoules of energy. What is the potential difference PD between the cloud and the Earth? A. 0.30 megavolt, B. 7.5 megavolt, C. 300 megavolts, or D. 680 megavolts. Okay, to determine the potential difference between the cloud and the Earth, we need to calculate using the formula energy E equals VIT, where V is the voltage, I is the current, and T is the time. Then we rearrange the formula to make V the subject, hence it becomes V equals E over IT. Now we can substitute all the values given. The energy is 450 times 10 to the power of 6 joules. The current is 300 times 10 to the power of 3 ampere, and the time is 5.0 times 10 to the power of negative 3 seconds. Then we calculate everything here. We get the voltage is 300,000 volts or 0.3 megavolts. Hence, the answer is A, 0.30 megavolts. Question 30. Voltage current readings are obtained from different electrical components. Which readings are for a 3.0 volt, 0.060 amps filament lamp? This is the voltage current reading for option A, option B, option C, and option D. To obtain the answer for this question, first we need to calculate the resistance for each option using the formula V equals IR, where R equals V over I. So after calculation, this is the resistance for option A, this is the resistance for option B, option C, and option D. Then let's recall the VI curve for a filament lamp. So this is the VI curve for a filament lamp. As you can see from this graph, filament lamp is non-ohmic, which means it doesn't obey Ohm's law because the graph is a curve, not a straight line. Resistance can be obtained by the gradient of the graph. As you can see from the graph, initially the gradient is not steep, and at the end the gradient is very steep, which means that initially the resistance increases slowly, then it increases rapidly. So among these four options, option A is the answer. Question 31. 4 pieces of wire made of the same material are connected in turn between terminals P and Q in the circuit. So here is the circuit. In which wire is the current largest? So here are a few options where we will change the length of the wire and the diameters of the wire. Okay, so we can have the length of wire either 10 centimeters or 20 centimeters, and the diameter of the wire is either 0.4 centimeters or 0.8 centimeters. Okay, so this question wants to have the largest current. Hence, to obtain the answer, we need to refer to the formula for resistance R equals rho L over A. So to obtain the largest current, from this formula, we need to have the smallest resistance, which means the length is the shortest, the area is the largest. Okay, to determine the area is the largest, we need to have the diameter is the largest. Okay, so among these options here, the answer will be B, where the length will be the shortest between 10 and 20, so 10 is shorter, and the diameter we need to be the larger between 0.4 and 0.8, so 0.8 will be larger. Question 32. A circuit contains 4 ammeters A1, A2, A3, and A4. So here is the circuit. The reading on A1 is 4.0 amps and the reading on A2 is 3.0 amps. Which row gives the readings on the other 2 ammeters? So here are the options. For the reading on A3, it is either 1.0 amp or 3.0 amp, and the reading for A4, it is either 2.0 amp or 4.0 amp. So to obtain the readings on A3 and A4, let's look at the circuit. So the reading on A1 is equals to the reading of A2 plus with the reading of A3. Hence, the reading of A2 will be A1 minus A3. So given the value of A1 is 4 and A3 is 3. Hence, the reading on A2 is 1.0 amps. And the reading on A4 will be equals to the reading of A1, which is 4.0 amps. Hence, the answer will be B. Reading on A3 is 1.0 amps and reading on A4 will be 4.0 amps. Question 33. The diagram shows two circuits. Here is the diagram. The voltmeter readings are shown next to the voltmeters. Which row is correct? So here are the options. In circuit 1, is V equals to V1 equals to V2 or V equals to V1 plus V2. In circuit 2, is V equals V3 equals to V4 or V equals to V3 plus V4. To obtain the answer for this question, let's study the circuit one by one. In circuit 1, the two resistors are connected in series. So these two resistors are connected in series. So the sum of the potential difference between these two resistors are equals to V. Hence, V equals to V1 plus V2. In circuit number 2, the two resistors are connected in parallel, which means that the voltage that are connected in parallel are the same. Hence, V equals V3 equals to V4. So the answer for this question will be C. Question 35. The diagram shows the wiring of a heater in a metal case. Here is the diagram. Which wire is connected to each terminal? Here are the options. So basically it is asking whether X, Y, and Z are they connected to the live, neutral, or the earth wires. So to obtain the answer for this question, let's recall how we want to connect the live, neutral, and the earth wire. So for the live wire, it needs to connect to the switch to ensure that there is no current flow through it when switch is off. For neutral wire, it needs to connect to the heater to complete the circuit. While for the earth wire, it needs to connect to metal casing to flow out any excess current to the ground. Hence, the answer will be C. X is connected to the neutral wire, Y is connected to the earth, and Z is connected to the live wire. Alright, because as you can see, Y is connected to the metal case, X is to the switch, so this will be the live wire, and Z is to connected to the heater to complete the circuit. Question 36. A beam of charged particles enter a magnetic field and charges direction as shown. So here is the diagram. Which row gives the sign of the charge on the particles and the direction of the magnetic field? So here are a few options. So whether the charge on the particle is negative or positive, and the direction of the magnetic field, is it from bottom of the page to the top of the page, or out of the page, or from the top of the page to the bottom of the page? Okay, so to obtain the answer for this question, we need to refer to the Fleming's left hand rule. So this is Fleming's left hand rule. The index finger will point to the direction of the magnetic field from the north pole to south pole. The middle finger will point the direction of the current flow, and the thumb will point at the direction of the force. So based on this diagram, as you can see, the beam of charged particles flow at first is flowing horizontally and then bend downwards, which means the force is at this direction. Okay, so what you have to do is your left hand have to be in Fleming's left hand rule, and then your thumb will point downwards. When your thumb is pointing downwards, your finger or your index finger will point out of the page. So this will be the direction of the field, which is out of the page. And your middle finger will point at this direction. So this is the direction of the current flow. As you can see, the charged particles is flowing opposite the direction of the current flow. Hence, the charged particle is negative. So the answer for this question will be B. Charge on particle is negative and the direction of the magnetic field is out of the page. Question 37. Each of two parallel wires carries a current I. The currents are in opposite directions. Which diagram shows the magnetic field pattern around the wires and the directions of the force F acting on the wires? So here are the few options. So to obtain the answer for this question, we need to refer to the right hand grip rule. So for the first piece of wire, the current is flowing outwards. So we have to hold our right hand in this manner. The thumb is pointing up, and imagine the current is flowing from the bottom to the top. Okay, so the thumb will show the direction of the current flow, and the remaining fingers will be the direction of the magnetic field. So if we observe this pattern from the top, this is what we will see, where this is a dot here, which means the current flows out from the plane and the magnetic field is in the anti-clockwise direction. Next, we go to the second piece of wire where the current is flowing downwards. So our thumb will point downwards, which shows the current is flowing downwards. The remaining of the fingers will show the field. And if you observe from the top here, we can see that this conducting wire, the current flows into the plane and the field is in the clockwise direction. Now, when these two conducting wires are placed close to each other, the resultant magnetic field will be in this manner, where the magnetic field between these two conducting wires is very strong. Hence, the force will point for the left hand side wire will point to the left, and the right hand side wire will point to the right. So that means this wire will move to the left and this wire will move to the right. So the answer will be D. Question 38. A bar magnet is inserted into the top end of a solenoid. Here is the diagram to illustrate the situation. Inserting the bar magnet induces a current in the solenoid, and the solenoid then behaves as an electromagnet. The bar magnet is inserted into the solenoid second time, the same way around, but more quickly. Which row is correct? So here are a few options. Basically, it is asking what is the magnetic pole produced at the top of the solenoid as the bar magnet is inserted? Is it north pole or south pole? And how is the effect of the strength of the magnetic field due to the solenoid of inserting the bar magnet more quickly? Is it becoming stronger or no difference? Okay, so to get the answer for this question, first you will need to relate to the Lenz's law, which states that the induced electric current always flows in the direction opposes the motion or change that induces it. Okay, which means that if this is the north pole trying to enter the solenoid here, this end of the solenoid will also induce a north pole trying to oppose this motion. Okay, the next one asking what will happen to the effect of the strength when this bar enter the solenoid more quickly. So to answer this question, we need to relate it to the Faraday's law, which states that the electromotive force EMF induced in a conductor is proportional to the rate of change of magnetic flux linkage through the conductor. So the speed increases the rate of change of magnetic flux linkage. Okay, in other words, the faster the bar magnet enter the solenoid, then the stronger of the magnetic field that is induced. Hence, the answer will be A. Question 39. The diagrams shows two waveforms P and Q displayed on an oscilloscope. The oscilloscope settings are the same for both waveforms. So here are the diagrams. The frequency of waveform P is 300 Hz. What is the frequency of waveform Q? A. 90 Hz, B. 200 Hz, C. 450 Hz, or D. 500 Hz. Okay, so to obtain the answer for this question, first let's look at the waveform P. So this will be the period of the waveform P. Let's label it as Tp. So from the frequency formula, F equals to 1 over T, and the period of waveform P, Tp will be equals to 1 over Fp, which is 1 over 300S. So in other words, 1 unit of the oscilloscope will be the T, which is half of the period of waveform P, which means 1 over 300 divided by 2 will have 1 over 600 seconds. Now, this will be 2 units of the scale or the x direction for the oscilloscope, and it is 1.5 of the period of waveform Q. So 1.5 TQ equals to 2T. That means the period of Q will be 2T divided by 1.5. They will substitute the value of T, which is 1 over 600. Calculate TQ, we have 1 over 450 seconds. In other words, the frequency of waveform Q will be 1 over the period of waveform Q, which is 450 Hz. Hence, the answer is C, 450 Hz. Question 40. A transformer has 500 turns on the primary coil and 1500 turns on the secondary coil. The current in the primary coil is 0.60 ampere. Losses in the transformer cause the current in the secondary coil to be 90% of the value of an ideal transformer. What is the current in secondary coil? A. 0.18 amp, B. 0.20 amp, C. 1.6 amps, or D. 1.8 amps. So to get the answer for this question, you need to use the transformer formula Vp over Vs equals Np over Ns, where Vp is the voltage of the primary coil, Vs is the voltage of the secondary coil, Np will be the number of turns in the primary coil, and Ns is the number of turns in the secondary coil. Then, given that Np is 500 and Ns is 1500, so Vp will be equals to 1/3 of Vs. Now, the power at the secondary coil is 0.9 of the power at the primary coil. So Vs Is equals 0.9 Vp Ip. So Vp is 1/3 of Vs, Ip is 0.6 amps. So Vs cancel with Vs, hence Is equals 0.18 amps. So the answer will be A, 0.18 amps.